Greetings to all. In the previous video, we discussed about mutual information and the properties of mutual information. In this video, let's discuss on the topic discrete memoryless channel. In digital communication, channel plays a major role because if you want to transmit any data from the input, okay, it passes through the channel before it reaches the destination. Therefore, channel plays a major role, right? We all know that. Now, what is discrete channel? Okay, so we call a channel to be discrete if both the input and the output variable are discrete. Okay, so at a given point of time, for a discrete input, we get a discrete output. Therefore, we can call that as a discrete channel. Okay, so the topic is discrete memoryless channel. Why do we call memoryless? We all know that the channel is called memoryless if the current output depends only upon the current input. Okay, it does not depend upon either the previous input or the past output. We call the channel to be memoryless if the current output depends only upon the present input. That's why we call this discrete memoryless channel. Okay, there are different types of discrete memoryless channels. Okay, so each one can be characterized by the channel matrix, or you can also call it the probability transition matrix. Okay, so based on the probability transition matrix, the characteristics of the channel changes, and let's see what is this probability transition matrix. Okay, so in general, okay, for any discrete memoryless channel, we can define the channel matrix or the probability transition matrix as P is equal to, okay, P of y1 comma x1, P of y2 comma x1, P of y1 comma x1. Given we have m outputs, and P of y1 comma x2, P of y2 comma x2, P of ym comma x2, etc. up to P of y1 comma x1, P of y2 comma xn, etc. up to P of ym comma xn. So what we see here is we have n inputs and m output. Okay, this is a general description of which is called as probability transition matrix. Okay, so in this probability transition matrix, what we should know is each row represents the fixed input. Okay, so if you see the first row, x we call as input. Okay, x is the input, so it's x1, x1, x1. Okay, that's for example. So each row of the matrix has a fixed input. Okay, and each column of the matrix has a fixed output. If you see the first column, it's y1. Second column is y2. Okay, so the last column is yn. So each column of the matrix has a fixed output. The other point that we should know is the summation of all the transition probability along the row is equal to 1. If you just add the probabilities of each row, it should be equal to 1. That is another important property of this probability transition matrix. Okay, then let's discuss about the different types of channels. Okay, the first one is binary communication channel. Okay, so from the name itself, it is known as binary. Binary means 2. So it's definitely going to have only 2 inputs. So 2 inputs and 2 outputs. So from the name itself, we can give the definition. When only 2 symbols are transmitted to a discrete channel, it's called as a binary communication channel. You see this graph. We have 2 inputs. We have x1 and x2, and which has a probability like x1, and x2 has a probability p of x2. Okay, so we output y1 and y2, and the different probability. Okay, this denotes P of y1 by x1, this denotes P of y1 by x2, this denotes P of y2 by x1, and this denotes P of y2 by x2. Okay, so what is the probability of y1? From the figure itself we can quickly say the probability of y1 is going to be probability of x1 into probability of y1 by x1 plus this, because y1 is connected to this and this, so therefore probability of x1 into probability of y1 by x1 plus probability of x2 into probability of y1 by x2. That's what we can see here. Okay, what is y2? What is probability of y2? Probability of y2 is nothing but probability of x2 into probability of y2 by x2 plus this branch, right? Probability of x1 into probability of y2 by x1. Okay, so if you want to write a transition probability matrix for this, you can easily write it has two inputs and two outputs. So that if you just from the general description, okay, the transition probability will be just probability of y1 by x1, y2 by x1, then probability of y1 by x2 and y2 by x2. It stops. It is just 2 by 2 matrix. Okay.